Planet Mercury is too hot and too small to retain an atmosphere. However, it does have a tenuous and variable exosphere that is made up of hydrogen, helium, oxygen, sodium, calcium, potassium, and water vapor, with a combined pressure level of about 10 to 14 bar, which is 1/4,000,000th of Earth's atmospheric pressure. Scientists believe that this exosphere was formed from particles captured from the sun, volcanic outgassing, and debris kicked into orbit by impacts. And do you know, because of this lax of viable atmosphere, Mercury has no way to retain the heat from the sun. And that is the reason that the side that faces the sun can reach temperatures of up to 700 Kelvin or 27 Celsius, while the other side down to 100 Kelvin 173 Celsius. Surface observations of Venus have been difficult because of extremely dense atmosphere made out of carbon dioxide with a small amount of nitrogen. At 92 bar, the atmospheric mass is 93 times that of Earth's atmosphere, and as you all know, Venus is hottest planet in solar system. That means its surface temperature can go up to 735 Kelvin 462 Celsius. And the reason for this is CO2 reach atmosphere along with thick clouds of sulfur dioxide, which generates strongest greenhouse effect in solar system. And do you know that Venus's clouds, consisting mainly of sulfur dioxide and sulfuric acid droplets, scatter about 90% of the sunlight back into space. And Venus strong winds, which reach speeds of up to 85 meters per second. Planet Mars has a very thin atmosphere, which is composed of 96% carbon dioxide, 2% argon, and 89% nitrogen, along with traces of oxygen and water. Mars' atmospheric pressure ranges from 0.87 kPa, which is equivalent to about 1% of Earth's at sea level. Because of its thin atmosphere and its greater distance from the sun, the surface temperature of Mars is much colder than what we experience here on Earth. The planet's average temperature is -46 Celsius with a low of -143 Celsius during the winter at the poles, and a high of 35 C during summer and midday at the equator. The planet also experiences dust storms, which can turn into what resembles small tornadoes. Larger dust storms occur when the dust is blown into the atmosphere and heats up from the sun. Trace amounts of methane have also been detected in the Martian atmosphere, with an estimated concentration of about 30 parts per billion. It occurs in extended plumes, and the profiles imply that the methane was released from specific regions, the first of which is located between Isidis and Utopia Planitia 30 degrees north to 60 degrees west, and the second in Arabia Terra 0 degrees north 310. Much like Earth, Jupiter experiences auroras near its northern and southern poles. But on Jupiter, the auroral activity is much more intense and rarely ever stops. Intense radiation, Jupiter's magnetic field, and the abundance of material from minute volcanoes that react with Jupiter's ionosphere create a light show that is truly spectacular. Jupiter also experiences violent weather patterns. Wind speeds of 100 meters per second are common in tunnel jets and can reach as high as 620 kilometers per hour. Jupiter is perpetually covered with clouds composed of ammonia crystals and possibly ammonium hydrosulfide, which located in the tropopause and are arranged into bands of different latitudes, known as tropical regions. The cloud layer is only about 50 km deep and consists of at least two decks of clouds, the thick lower deck and the thin clearer region. There may also be a thin layer of water clouds underlying the ammonia layer, as evidenced by flashes of lightning detected in the atmosphere of Jupiter, which would be caused by the water polarity creating the charge separation needed for lightning. The outer atmosphere of Saturn contains 96.3% molecular hydrogen and 3.25% helium by volume. This gas giant is also known to have heavier elements, though the proportions of these relative to hydrogen and helium is not known. Trace amounts of ammonia, acetylene, methane, propane, phosphine and methane have been also detected in Saturn's atmosphere. The upper clouds are composed of ammonia crystals, while the lower level clouds appear to consist of either ammonium hydrosulfide or water. On occasion, Saturn's atmosphere exhibits long-lived ovals, similar to what is commonly observed on Jupiter. Whereas Jupiter has the Great Red Spot, Saturn periodically has what's known as the Great White Spot, Great White Oval. This unique but short-lived phenomenon occurs once every Saturnian year, roughly every 30 Earth years, around the time of the Northern Hemisphere summer solstice. As with Earth, the atmosphere of Uranus is broken into layers, depending upon temperature and pressure. Like the other gas giants, the planet doesn't have a firm surface, and scientists define the surface as the region where the atmospheric pressure exceeds 1 bar the pressure found on Earth at sea level. Using these reference points, Uranus' atmosphere can be divided into 3 layers. The first is the troposphere, between altitudes of -300 km below the surface and 50 km above it, where pressures range from 100 to 0. 1 bar. The second layer is the stratosphere, which reaches between 50 and 4,000 km and experiences pressures between 0.1 and 10 raised to -10 bar. Within the troposphere are layers of clouds, water clouds at the lowest pressures, with ammonium hydrosulfide clouds above them. Ammonia and hydrogen sulfide clouds come next. Finally, thin methane clouds lay on the top. Winds on Uranus can reach up to 900 km/h, creating massive storms like the one spotted by the Hubble Space Telescope in 2012. Similar to Jupiter's Great Red Spot, this dark spot was a giant cloud vortex that measured 1,700 kilometers by 3,000 kilometers. At high altitudes, Neptune's atmosphere is 80% hydrogen and 19% helium, with a trace amount of methane. As with Uranus, this absorption of red light by the atmospheric methane is part of what gives Neptune its blue hue, although Neptune is darker and more vivid. Neptune's atmosphere is subdivided into 2 main regions, the lower troposphere where temperature decreases with altitude, and the stratosphere where temperature increases with altitude. The boundary between the two, the tropopause, lies at a pressure of 0.1 bars. The stratosphere then gives way to the thermosphere at a pressure lower than 10 to 5 to 10 to 4 microbars, which gradually transitions to the exosphere. Because Neptune is not a solid body, its atmosphere undergoes differential rotation. The wide equatorial zone rotates with a period of about 18 hours, which is slower than the 16-1-hour rotation of the planet's magnetic field. By contrast, the reverse is true for the polar regions, where the rotation period is 12 hours,